Hey guys, this video covers more examples for Chapter 7, Section 1, dealing with using the trig identities that we know to find exact values of some trig equations. So if your reference sheet is not out that has the identities on it that we discussed yesterday, go ahead and make sure that's out so that you kind of get in the habit of referring back to that to know which identities apply to a given scenario. So we're just going to jump right on in. It's almost kind of a continuation of yesterday's video with some of these examples. Okay, so my first example is the cotangent of theta equals -8 within the parameters of 270 degrees is less than theta is less than 360 degrees. And I want you to find the cosecant of theta given that information. So just to recap, this is what you want to find. 270 degrees is less than theta is less than 360. This is telling us that our angle theta, if you use what you know about the unit circle, that this would be in quadrant 4. So it's saying the particular angle needs to be in quadrant 4. And then given the cotangent of theta is equal to -8. So your job is to find a relationship. Is there a trig identity that relates cotangent to cosecant? And if so, what is it? So as you're looking at your reference sheet, hopefully you come across one that will relate both of them. Particularly one of your Pythagorean identities that has 1 plus the cotangent squared theta is equal to cosecant squared theta. Okay, so now what we can do is substitute in what we know. So I know 1 plus, instead of cotangent squared theta, I know that cotangent of theta is -8. So I can plug in -8, don't forget to put squared, is equal to cosecant squared theta. So the goal is to find cosecant, to get cosecant by itself. So if we continue solving, this will be 1 plus -8 in parentheses squared is going to be a positive 64 equals cosecant squared theta. 1 plus 64 is 65. And then in order to get cosecant alone, we're going to go ahead and take the square root of both sides. And when we take the square root of something in algebra, it's going to cancel with this square, right? So we're just left with cosecant of theta, but then we get is plus or minus the square root of 65. Now, the deal is, back in our original given information, we're concerned with theta being in quadrant 4. Okay, so what that means is in quadrant 4, cosecant, we need to figure out, is that positive or negative? So recall, cosecant is the same thing as 1 over the sine of theta, right? So that's actually 1 over y. So in this case, in quadrant 4, we know that our y value must be negative. So in quadrant 4 implies y is negative. So in other words, our cosecant, which implies cosecant is also negative. Therefore, our answer, so that implies that the cosecant of theta is equal to negative square root of 65. Let's do another. Example 2. Given the cosine of theta is equal to -2/3, with 90 degrees is less than theta is less than 180 degrees, find the sine of theta. So again, the sine of theta is what we're solving for. Theta must be between 90 and 180 degrees, meaning that this would be in quadrant 2. And then you want to look at your reference sheet and you want to find an identity that relates cosine to sine. And hopefully you'll get really good at this. Now there is one, it's sine over cosine equals tangent, but that throws in a third trig function that you don't want to throw in another one unless you have to. So there's a better choice that has only sine and cosine, which will be sine squared theta plus cosine squared theta is equal to 1. And then if we substitute in what we know, we don't know sine squared, so I'm going to leave that alone, plus cosine squared theta. Well, I know that cosine is negative 2/3, so that'll be negative 2/3 squared is equal to 1. And then if we keep simplifying, we get sine squared theta plus negative 2/3 squared. It's a negative times a negative, so it'll be a positive 4/9 equals 1. And then if we subtract 4/9 from both sides, then we get that the sine squared theta is equal to 1 minus 4/9 is 5/9. And then in order to get sine of theta by itself, we're going to take the square root of both sides, which when we do so, we get that sine of theta is equal to, again, plus or minus the square root of 5/9. Now, before we even decide which one this should be, plus or minus, this simplifies even further. This is going to be plus or minus the square root of 5 over the square root of 9 is 3. Okay, so remember, a radical is not simplified if there's a square number inside of it and or if there's a fraction under your radical. So this takes care of both. This gets rid of the fraction in the square number of 9. Now again, we need to go back to the stipulations of the problem. In quadrant 2, the sine value, dealing with the y's, right? So in quadrant 2, the sine value over here, the y values must be positive. Positive. So, why am I doubting myself? Oh, no, that's correct. Okay. Sorry, sine is positive. Therefore, our answer is that the sine of theta is equal to the square root of positive square root of 5 over 3. Okay, let's do one more. Last one, number 3. I want you to find the tangent of theta, or sorry, given that the tangent of theta is 2/3, with the stipulation pi is less than theta is less than 3 pi over 2, find the cosine of theta. So we're trying to find the cosine of theta. Theta being between pi and 3 pi over 2, again, you got to be really good with your unit circle here. This is pi over 2. This is 1 pi. This is 3 pi over 2. And then it goes back to 2 pi over here. So being between pi and 3 pi over 2 means that we must be in quadrant 3. So you need to find an identity that relates tangent, our starting point, to cosine. And as you're looking at your sheets, I'll give you a hint, you're not going to find one. We don't have an identity that straight up gets from tangent to cosine. So you're going to need to choose two functions. So the idea is that if you want to go from tangent to something else, and then to get your cosine answer. So basically you want to look for two of your trig identities that one has tangent and something, and the other one has that same something and cosine. Or, you could, in this case, I'm going to throw in a third. So I solved it one way. I'd be curious to see if, given the opportunity, if you solved it a different way using some other identities. But here's what I did. So it's kind of in two steps. So I first said, So part A is kind of like, or let's see, let me label this with identities. Okay, so one of the first ones that we have is just a quotient identity. Quotient identity, which is that the sine of theta over the cosine of theta is equal to the tangent of theta. And then I'm going to substitute in what I know. So this implies that I don't know what the sine is, so I'm going to leave that alone. Over, I also don't know what the cosine is, so I'm going to leave that alone, equals the tangent of theta is 2/3. Okay, so what I'm realizing is that I can get from tangent to cosine if I solve this one for sine. So if I try to solve this for sine, I can go ahead and multiply my entire problem by cosine of theta, right? Because it's being divided by the cosine of theta. So if I multiply it by the cosine of theta, it'll cancel. So if I do that, then I get, on the left side, I just get sine of theta because that cosine of theta cancels. And then on the right-hand side, I get 2/3 times the cosine of theta. So I've now rewritten, using the quotient identity, my tangent in the form of sine. Okay, next, I'm going to use one of the Pythagorean identities, which is going to relate sine to cosine only. So then I can use sine squared theta plus cosine squared theta is equal to 1. So what will happen here is, instead of sine, I'm going to use what we plugged in here into this spot. So that's going to be, in parentheses, 2/3 times the cosine of theta squared plus cosine squared theta equals 1. And here's the reason that I put parentheses here on the outside. You need to make sure, and not just 2/3 cosine squared theta, you need to make sure when you square that you also square this 2/3. Okay, so when you square that 2/3, that'll be 4/9 times the cosine squared theta plus cosine squared theta equals 1. And then remember, that's what I'm trying to find. I'm trying to set up cosine, so I'm getting really close. I just need to combine these cosine values. Well, they're, kind of treat them like variables. This one has a coefficient of 4/9. This one has a coefficient of 1. So then 4/9 plus 1 is going to be 13/9 times cosine squared theta is equal to 1. And then I'm almost got cosine squared theta isolated. So if I want to get rid of 13/9, you could do that in a couple different ways. You can think of dividing both sides by 13 over 9, or I like to think about it as multiplying both sides by the reciprocal, by 9 over 13. So then if we do that, on the left-hand side, we're left with cosine squared theta equals 1 times 9 over 13 is 9 over 13. And then to isolate cosine, we take the square root of both sides. Therefore, we have the cosine of theta is equal to plus or minus the square root of 9 over 13. So again, this is not simplified. So this will be plus or minus. The square root of 9 is 3. But we cannot take the square root of 13, so that one would stay in parentheses, or sorry, stay under the radical. But this is also not simplified. So we'll rationalize that denominator to get plus or minus 3 square roots of 13 over 13. We will go back to our original stipulations of the problem, that this has to be in quadrant 3, and I'm looking for cosine. Well, cosine deals with x values, and x values in quadrant 3 are negative. Therefore, we're going to write our final answer as the cosine of theta is equal to negative 3 square roots of 13 over 13. So some tips going forward for the assignment that accompanies this. Try something. If you pick one identity and things just get kind of messy, or you don't get very far, or you get to a roadblock, that's okay. Try something else. And don't hesitate to leave it on your paper, but like cross it out. If you erase everything, then sometimes you might kind of spin in circles trying to figure out what you need to do. So, take 10 sheets of paper if you have to, exhausting some different ideas. So again, look at tips with or there are some tips in your textbook and the tips on the reference sheet too. We're not exactly proving necessarily showing why an identity is an identity, but in this case, make sure that you are trying to find a link between the given function or the given ratio and the final ratio. And just like this one, number 3, sometimes you might have to take a midway point in between. But the moral of the story is don't hesitate to try something because you only have a limited number of identities. So I guarantee it will simplify in some way, shape, or form.